Hello everyone. At the outset, let me introduce myself. I am Dr. Venkateswara, Assistant Professor, P.G. Department of Chemistry, Y.N.College.Narsapur. In the last video, that is mole concept part 1, we had gone through the mole concept and we came to know that mole is a unit by which we can quantify the chemical substances or chemical compounds. And moreover, we came to know that different formulas to calculate the number of moles, that are mole is equal to gram atom is equal to gram molecule is equal to weight in grams by gram atomic weight, and it is equal to weight in grams by gram molecular weight, and it is equal to Avogadro's constant, and it is equal to volume of gas is equal by 22.4 liters. These are the formulas, different formulas by which we can calculate the number of moles. Now we shall do the problems based on these formulas. In this context, I would like to say something, that is, problems are application of concepts what we understood or what we learned. Therefore, if you are sound at concept, then it will be easy to solve the problems. Okay. Due to time-bound limitations in this mode, I shall try to sum up these applications with 8 to 10 problems. Let us see the problems one by one. Problem 1. Calculate the number of gram atoms in 1 kg of helium atom. This is the problem. Already I told you that solving the problem is nothing but application of concept what we understood or what we learned. Here, what we have to calculate is number of gram atoms in 1 kg of helium atom. We have formula for gram atoms, that is, gram atom is equal to weight by gram atomic weight. Here, weight by gram atomic weight. How would I know this formula is best suit for this to solve this problem? Because here, what is given in the problem? 1 kg of helium. That amount is in kgs, and we can convert that kgs into grams, and we have the formula to calculate the gram atoms is gram atom is equal to weight by gram atomic weight. So 1 kg means 1000 grams. Therefore, weight is equal to 1000 grams by gram atomic weight. Gram atomic weight of helium. So, gram atomic weight of helium is 4. Therefore, 1000 by 4, that gives 250. Therefore, 250 gram atoms are there in 1 kg of helium atom. Problem 2. Problem 2 is calculate the number of gram atoms in 12.044 into 10 power 23 atoms. Okay, we know gram atom is equal to 1 mole, and 1 mole contains 6.023 into 10 to the power of 23 atoms. So from the problem you should understand what they given and which formula is to be applied. You have to know that which formula is to be applied. So here what we have to calculate the number of gram atoms in 12.044 into 10 to the power of 23 atoms. We know 1 gram atom is equal to 1 mole, and 1 mole contains 6.023 into 10 to the power of 23 atoms. Therefore, 1 mole contains 6.023 into 10 to the power of 23 atoms. Then 12 into 0.44 into 10 to the power of 23 atoms equal to how many moles or how many gram atoms? Here what they asked, number of gram atoms. So 1 gram atom contains 6.023 into 10 to the power of 23 atoms, and 12.044 into 10 to the power of 23 atoms equal to how many gram atoms? Okay, it is very simple. Okay, we are all doing this type of problem from our childhood. So this can be calculated by cross multiplication, that is 12 into 0.44 into 6.023 by 12 into 0.44 into 10 to the power of 23 by 6.023 into 10 to the power of 23. Therefore, that gives approximately 2. So, 2 gram atoms are there in 12.044 into 10 to the power of 23 atoms. It is very simple. 1 gram atom contains 6.023 into 10 to the power of 23 atoms. Then 12.044 into 10 to the power of 23 atoms equal to how many gram atoms? It is just very simple. It is cross multiplication. It is nothing but cross multiplication. Okay. Problem 3. Calculate the number of atoms in 4 grams of calcium. So in the problem what they gave, 4 grams of calcium. So when they gave 4 grams, that is when they provided the weight of any chemical substance, then we should equate the weight to moles. That is, here we know mole is equal to weight by gram atomic weight. So we should equate mole is equal to weight by gram atomic weight. So mole is equal to weight by gram atomic weight. So here the weight is 4 grams, and gram atomic weight of calcium is 40, because the element calcium has atomic number 20 and its atomic weight of 40 point something, but usually we took 40 as its atomic weight. So atomic weight as 40 grams. Therefore 4 by 40 means 1 by 10 and is equal to 0.1 mole. 0.1 mole. Okay, so this is 0.1 mole. We know 1 mole contains 6.023 0.03 into 10 to the power of 23 atoms. Okay, then 0.1 mole contains how many atoms? Okay, so it is very simple. 0.1 into 6.023 into 10 to the power of 23 by 0.1 into 6.023 into 10 to the power of 23 atoms. So we can calculate this equation as 0.1 means if you multiply this 0.1 with the 10, then it becomes 1. Then 6.023 into 10 to the power of 22 is the answer. Okay, this is one method. Here I am equating this 4 grams, and here I am calculating the moles from weight to gram atomic weight ratio. Here we know that there is another way to solve this problem, that is 40 grams. 40 grams means 1 gram atom of calcium. So 40 grams atomic weight of calcium is 40 grams, and that is equal to 1 gram atom. And 40 grams is equal to 1 gram atom, and 40 grams contains 6.023 into 10 to the power of 23 atoms. Then 4 grams contains how many atoms? Then again it is also a cross multiplication, that is 4 by 40 into 6.023 into 10 to the power of 23. Okay, which is also gives 1 by 10. Okay, 1 by 10 into 6.023 into 10 to the power of 23, and of course which is equal to 6.023 into 10 to the power of 22. Here what you should observe is that we can calculate the number of moles from weight by gram atomic weight. Okay, weight by gram atomic weight, or we can calculate this number of atoms from weight or from number of moles. Okay, so in these two ways we can calculate this problem. Why I am giving these two ways? My intention is to know this way of solving the problem, right? Okay, problem 4. Calculate the number of molecules in 2.2 grams of CO2. Okay, from this problem you should know one thing is that what they give CO2 molecule and what they give 2.2 grams. Okay, we know 1 mole is equal to, okay, so here is the formula. 1 mole, I am equating all the relations in the top of this board. On the top of this board, you should kept in your mind all these relations. Mole is equal to gram molecule, because here CO2 is a molecule. So gram molecule, we have to use the formula gram molecule. Okay, so gram molecule is equal to 1 gram molecule means 1 mole. So 1 gram molecule is equal to weight by gram molecular weight. Okay, of course 1 gram molecule is equal to 1 mole. Here weight is 2.2 grams. Here weight is 2.2 grams. Okay, here weight is 2.2 grams. So gram molecular weight of CO2 is 44. Okay, by which we can calculate number of molecules, number of gram molecules or number of moles. 2 by 2.2 by 44, that gives 0.05. So which is equal to 0.05 moles or 0.05 moles. We can calculate from 0.05 moles or 0.05 gram molecule. 1 gram molecule contains 6.023 into 10 to the power of 23 molecules. Then 0.05 gram molecule of CO2 contains how many atoms? Okay, so you simply multiply this equation, you can get that is 0.05 into 6.023 into 10 to the power of 23, which gives number of molecules, because 1 gram molecule contains 6.023 10 to the power of 23 molecules. Then 0.05 gram molecule contains 0.05 into 6.023 into 10 to the power of 23 molecules. Okay, in that way we can calculate number of gram molecules. You please make sure this multiplication. You please do that multiplication, you can get the answer. Okay, that is one way. And another way is very simple. 44 grams. Another way is 44 grams is equal to 1 gram molecule. 44 grams of CO2 is equal to 1 gram molecule or 1 mole. This contains 6.023 into 10 to the power of 23 molecules. Okay, then 2.2 grams contains how many molecules? Again, we can do that 2.2 by 44 into 6.023 into 10 to the power of 23. Okay, so again this gives 0.05 into 6.023 into 10 to the power of 23. Again, this multiplication gives the value, whatever the value that we get here, that is equal to the value we get here. Okay, so if you why I am elaborating this problem solving is you should know what is I am applying the concept what we learned in the earlier classes. Okay, problem 5. Calculate the volume occupied by 35.5 grams of Cl2 at STP. Whenever they give the molecule, then you have to write molecular weight. Okay, Cl2, its molecular weight is 71 grams, because one chlorine 35.5, so two chlorines 35.5 plus 35.5, that gives 71 grams. Okay, so 71 grams is equal to 1 gram molecule. Already I told you 1 gram molecule means gram molecular weight of any molecule is equal to 1 mole or 1 gram molecule. So 71 grams is equal to 1 gram molecule, and 1 gram molecule is equal to 1 mole. And we know that 1 mole of any gas occupies 22.4 liters volume. Okay, so 1 mole of any gas occupies 22.4 liters. Okay, 1 mole, and that means 71 mole is equal to here how much? 71 grams. So 71 grams occupies 22.4 liters. Then 35.5 grams occupies how many liters? It is very simple. We can cross multiply this. We can cross multiply this relation. Then we get 35.5 by 71 into 22.4 liters. That gives the volume occupied by 35.5 grams of chlorine. Okay, so there is no ambiguity or there is no difficulty in the problems, because you just know how we convert the relations. Problem solving is just applying the concept what we understood or what we learned. You just interconvert the relations. Okay, 71 grams, but they give 35.5 grams of Cl2 gas. But we don't know the relation, we don't have the relation between weight and gas, and weight and volume occupied by the gas. Then we have to convert that 35.5 grams into 1 mole. We know 71 grams equal to 1 gram molecule, and 1 gram molecule is equal to 1 mole, and 1 mole occupies 22.4 liters volume. That is Avogadro's concept. So 1 mole occupies 22.4 liters. 1 mole means here 71 grams. And what they ask is 35.5 grams of chlorine. Then you just simply cross multiply this equation, then you get the volume occupied by 35.5 grams of Cl2 gas. Okay, you please calculate this 1 by 2. I think it is 1 by 2 into 22.4 liters. That is 11.2 liters. Okay. Problem 6. Calculate the number of moles in 0.72 grams of glucose and 5.6 liters of CH4. Okay, we know here what they given 0.72 grams. Okay, and what they asked to calculate number of moles. So number of moles is equal to, we know number of moles is equal to weight by gram molecular weight. So weight, what they given 0.72 grams, and the gram molecular weight is gram molecular weight of glucose. The glucose molecular formula is C6H12O6. Its molecular weight, which is 180 grams. So 0.72 grams by 180. We can get the number of moles, that is 0.004 moles. And another problem B, number of moles in 5.6 liters of CH4. We know number of mole equal to volume of gas by, this is mole is equal to volume of gas by 22.4 liters. They gave 5.6 liters of methane. Then you just substitute these values in this equation. Number of moles is equal to volume of gas by 22.4 liters. So volume of gas is 5.6 liters by 22.4 liters, which comes out to be 0.25 moles. Okay, you please calculate the fractions, okay, by your own way. Okay, time is not sufficient enough to calculate all these fractions. Please do these fractions. Okay, problem 7. Calculate the weight of 0.1 mole of Na2CO3 and 3.011 × 10⁻23 molecules of SO2. Okay, problem A. We know that mole is equal to weight by gram molecular weight. Okay, how would I know to write this formula? Because Here they give Na2CO3 molecule. Therefore, you have to write the mole formula with respect to the gram molecular weight of molecule. Okay, so mole is equal to weight by gram molecular weight. So here how many moles they give? 0.1 mole, and the weight by they asked to calculate the weight. So weight by gram molecular weight of Na2CO3. Gram molecular weight of Na2CO3 is equal to 106 grams. Therefore, weight is equal to 0.1 into 106. Therefore, 0.1 means 1 by 10 and into 106. So 106 by 10 means 10.6 grams. Therefore, okay, 0.1 mole Na2CO3 weighs 10.6 grams. Next, problem B. Okay, so here 3.011 into 10 to the power of 23 molecules of SO2. Okay, we know 1 mole of SO2 molecule contains 6.023 into 10 to the power of 23 molecules. Okay, then 3 into 0.11 into 10 to the power of 23 molecules contains molecules equal to how many moles? Okay, it is just cross multiplication. 3 into 3.011 into 10 to the power of 23 by 6.023 into 10 to the power of 23, which comes out to be 1.2, the 1 by 2, which is equal to 0.5. Okay, we know number of moles. We know the number of moles, and we know mole is equal to weight by gram molecular weight. Mole is equal to gram molecular weight. So here number of moles is equal to 0.5 and weight is equal to gram molecular weight of SO2 is I think 64. So weight is equal to 0.5 into 64. Okay. Okay. Problem 8. How many atoms of each element are there in 9.8 grams of H2SO4? Okay, what they give 9.8 grams. We know molecular weight of H2SO4. Then we can calculate the number of moles. So number of moles is equal to 9.8 by 98, which is equal to 0.1 mole. 0.1 mole. And we know that 1 mole of H2SO4 contains 6.023 into 10 to the power of 23 molecules. And 1 molecule of H2SO4 contains 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. So what they ask to calculate how many atoms of each element are there in 9.8 grams of H2SO4. We know 1 mole of H2SO4 contains 6.023 to 10 to the power of 23 molecules. Okay, so 0.1 mole of H2SO4 contains 0.1 into 6.023 to 10 to the power of 23 molecules. Okay, so and one more thing is to be kept in your mind that 1 molecule of H2SO4 contains 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. Okay, what they ask? How many atoms of each element? Okay, so there is a formula to calculate the number of atoms of each element in a molecule. That is number of atoms is equal to moles into Avogadro's constant into atomicity. Atomicity. Atomicity means number of atoms. Number of atoms of that particular element in that molecule. Okay, so number of atoms. Now we calculate the number of hydrogen atoms in the H2SO4 molecule, and 9.8 grams of H2SO4 molecule. Okay, so 9.8 grams of H2SO4 that is equal to 0.1 mole. So therefore number of moles is 0.1 and Avogadro's constant is 0.023 into 10 to the power of 23, because 0.1 mole contains 6.03 into 10 to the power of 23 molecules, and one molecule of H2SO4 contains 2 hydrogen atoms. Okay, and 0.1 into 6.03 into 10 to the power of 23, and how many hydrogen atoms are there? 2 hydrogen atoms. Therefore that is equal to 0.2 into Avogadro's constant. Next, this is for number of hydrogen atoms. Similarly, number of sulfur atoms. Number of sulfur atoms is equal to 0.1 into 1 sulfur atom, Avogadro's constant, into 1 sulfur atom, that is 0.1 into Avogadro's constant. Next, number of oxygen atoms. Number of oxygen atoms equal to how many moles? 0.1 mole into Avogadro's constant into 4. That is 0.4 into Avogadro's constant. Therefore, 9.8 grams of H2SO4, that is equal to 0.1 mole, and that 0.1 mole contains number of hydrogen atoms. Then 0.1 mole of H2SO4 contains 0.2 into Avogadro number of atoms, and number of sulfur atoms is equal to 0.1 into Avogadro number of atoms. Next, number of oxygen atoms equal to 0.4 into Avogadro number of atoms. 0.4 into Avogadro constant number of atoms. Right. Okay. Next problem is this: the weight of O2 gas liberated by heating 2.45 grams of KClO3. Okay, for example, if we want to do this problem, we have to know the stoichiometry of chemical reactions. Okay, in the next video, we shall apply the mole concept to chemical reactions, and we shall discuss the stoichiometry and equivalent weights of chemical compounds. Thank you.